All right, guys, getting into section 10.4 now, which deals with radical equations. So previously, we talked about adding, subtracting, multiplying, and multiplying radical expressions. Now we want to talk about how to actually solve radical equations and solve radical equations with something that are called extraneous solutions. So those are the two main ideas in the vocab for our section today, are radical equations and extraneous solutions, and we'll talk about what those are now. The equations that contain variables in the radicand, like for example, h equals 1.3 times the square root of L, are called radical equations because they have a radical in the equation. So to solve these, the basic idea is to isolate the desired variable on one side of the equation, then square each side of the equation to eliminate the radical. Remember, the square root in squaring are inverse operations. So to undo a square root, you have to square the square root. And remember, when you solve equations, what you do to one side, you do to the other side. So if you square both sides of a true equation, the resulting equation is still true. So for example, if a equals b, then a squared has to equal b squared. So if square root of x equals 4, then I square both sides, I get square root of x squared is equal to 4 squared, so x equals 16. And then if you substitute that back in the check, square root of 16 equals 4. Now that's a simple basic example to show you how these end up working out. So let's check out this example. So we have this situation here where you can estimate the hull speed that's of a boat, h, by using the formula h equals 1.34 times the square root of L, where L is the length of the sailboat's waterline. So you have like your boat here, and this is L, and that's the length of the sailboat's waterline. All right, so Idris and Sebastian are sailing in a friend's sailboat. They measure the hull speed at 9 nautical miles per hour. Find the length of the sailboat's waterline. Okay, so be careful. You're not just plugging 9 in for L, okay? The 9 represents h, the hull speed. So I take my equation and substitute 9 in for h. Now I want to solve for L. So remember, the first thing you have to do when you solve radical equations is isolate the radical first. So you have to divide off the 1.34, since it's multiplying, the inverse operation is divide. And you get about 6.72 equals the square root of L. Then to undo the square root, you square both sides. Therefore, your answer is L is about 45.16. So in the context of the problem, this sailboat's waterline length is about 45 feet because, again, L represents the length of the waterline in feet. Okay? All right. So you can check by substituting the estimate into the original formula. So if I take my original formula and substitute 45 in, 1.34 times the square root of 45 is 8.98. Now that's not exactly equal to 9 because I didn't put the exact answer in there. I put my estimate in. And my estimate comes out to a number that's very close to the 9 that was given. So I know my estimate is really close, and that's what an estimate is. It's a number that's very close to the exact answer. Okay? Had we put 45.16 in as our estimate, it would have been a little bit more accurate. Okay? All right, here's one for you to try. Go ahead and pause the video and hit play when you're ready to check it. Okay, so the equation v equals square root of 2.5 r represents the maximum velocity that a car can travel safely on an unbraked curve when v is the maximum velocity in miles per hour and r is the radius of the turn in feet. If a road is designed for a maximum speed of 65 miles per hour, what is the radius of the turn? So when you have a turn like this on your road, okay, your radius is right here. Okay, that's like your curve on your road. What is the maximum speed you can go for a given radius? That's what this equation tells us. Okay, now they're saying what should the radius be if the maximum speed is 65? So you have v equals square root of 2.5 r, and 65 equals the square root of 2.5 r. Now, a common mistake that students would make right here is to divide by the 2.5. But it's trapped, it's like trapped inside the square root. Now notice the square root is already by itself on one side of the equation. I don't have to divide anything off or add or subtract anything to get the square root part by itself. To get rid of the 2.5, I have to now get rid of the square root. So you square both sides at this step. Okay? So 65 squared is 422 or 4,225, and that equals 2.5 r. Now the 2.5 r is no longer trapped inside the square root, so you can divide everything by 2.5. And you get 1,690 equals r. So the radius should be 1,690 feet in the context of the problem to produce a curve at which you could go around the bend at 65 miles per hour. So you might think, wow, 1,690 feet is a big radius. Yes, and if you think about it, 65 miles an hour is pretty fast. So if you're going around a bend at 65 miles per hour, it better not be too sharp of a turn, or your car might flip over. You might not be able to take the curve and go off the road. All right? So to solve a radical equation, isolate the radical first, then square both sides. So let's take a look at this example here. So I have square root of a plus 5 plus 7 on the outside of the square root equals 12. So your first step is to get the radical part by itself. So I want to eliminate that 7. So subtract 7 from both sides, like this. And then you get square root of a plus 5 equals 5. Now the square root part is by itself on one side, and then you leave everything else out on the other side. Now you square both sides. So square root of a plus 5 squared gets rid of the square root, and 5 squared is 25. Now you simply subtract 5 from both sides, and you get a equals 20. Oops. So if a is 20, you can check it. You get square root of 20 plus 5 plus 7. Does that equal 12? Well, the 20 plus 5, 25 plus 5 is, I'm sorry, I put 25 in there. This should just be 20. 20 plus 5 is 25. Now don't add the 7 in yet, because the 7 is not in the square root, and the square root's kind of like a grouping symbol. In order of operations, you have to do the grouping symbol first. So square root to 25, you get 5 plus 7 equals 12, and that's true. Okay? Now, here's a couple for you to try. Go ahead and pause the video and hit play when you're ready to check it. All right, we're back. So for the first one, you add 2 to both sides to isolate the radical. So square root c minus 3 equals 6. Then you square both sides, and you get c minus 3 equals 36. Add 3, and you get c equals 39. Now, if you check that, you would have 39 minus 3 is 36. The square root of 36 is 6, and 6 minus 2 is 4. So I know that works. This one, you have to get rid of this 4 first, and you get square root of h plus 1 equals 10. Square both sides now because I have the radical by itself. Now, don't subtract the 1 first. You have to square first because the 1 is trapped inside the square root. You got to get rid of that first. So if I square both sides, I get h plus 1 equals 100. Subtract 1, and I get h equals 99. Now, if I substitute that into the original equation to see if it works, I would get 4 plus the square root of 99 plus 1, which ends up being square root of 100, which is 10, plus the 4 gives me 14. So I know that is correct. All right, so that's it for this one. Next time we're going to talk about, in the next video, something called extraneous solutions. So see you there.